So here we go, tangent line to a curve. Okay? This is my curve, and I want to find the equation for the tangent line at this point. So they've only given me the x coordinate of the point. I can easily find the y coordinate. I just plug it in here, right? So if I think about what this looks like, I don't even need to draw a picture to do this problem. But I am going to draw the picture just so that we get a little bit used to just sort of thinking about what this stuff looks like. So here's my curve, and my tangent line is going to be there. I need to find the equation for this tangent line. Now I put it through there. Let's see. At x equals 1, f of 1 equals 2. So this point is 1, 2. Okay, easy enough to find that. So I have the coordinates of the point. In order to write the equation of the line, I need the slope. So in order to do the slope, I need the derivative. So the derivative, so the slope m of our line is the derivative f prime of 1, right? So I'm just going to take a equals 1 in my difference quotient, and I'm just going to write that down. I'm going to use the form with the h. So it's f of 1 plus h minus f of 1 over h. Now, this is what f is. So now I'm just going to plug that stuff in there and go ahead and do this limit. So I have got 1 plus h cubed minus 1, plus 1, minus, notice I'm putting in these parentheses, 1 cubed minus 1, right? Plus 1. I apparently have decided function negative 1, but it's not, it's plus 1. Okay, so I have this sort of thing here. So I'm going to work this out. Happens to be that, right? And then I have plus 1 minus 2. Well, these constants canceled out, right? I've got plus 2 minus 2. And then I can see that, okay, I'll write it one more time just to be clear here. After I've canceled out my constants, I have 3h plus 3h squared plus h cubed in that part. Now, notice that just like all those examples we did last week, for each of these, if I put in h equals 0, I'm going to end up with a 0 over 0. So I know that I still need to do a bunch of work to evaluate my limit. But now at this point, I can factor out an h from everything in the top because the constants canceled out. So I can even write it carefully enough like this. H pulled out 3 plus 3h plus h squared over h. The h's cancel. Now I have a very nice easy limit to do, right? Limit as h goes to 0 of 3 plus 3h plus h squared. Now, when I put in h equals 0, I no longer have 0 over 0. In fact, I get 3 plus 0 plus 0, so I get 3. So that's going to tell me that the slope of my line is 3. So now what I have to do is I've got slope m is 3, and my point I had just found before was 1, 2. So I just have to write down the equation of a line. Now I usually use the point slope formula here. You may go ahead and if you don't like to use point slope, you want to use slope intercept and solve for the intercept, that's fine. I don't care how you do it. It's the same amount of work anyway, right? 3x minus 3 plus 2. So in the end, the equation of my tangent line is y equals 3x minus 1. Yay! All right, so that gives you an idea, right? The limit, it looks sort of familiar with stuff that we did last week for reasons, right? We did that to give you some practice with it. Most of the ones that we're going to do are going to follow some pattern that looks similar to ones that you did last week. So I'm going to do one more example. I'm going to do square root of 1 minus 3x at the point negative 1, 2. And by the way, you can see before I erase the picture that I made a pretty crappy looking picture, but it sort of looks kind of round, not quite right, but yeah. It should be a little bit steeper, right? But more or less, it's 2, 3, whatever. So it should have been a little bit steeper the way I did it because it's supposed to go through here. So let me actually, before I erase it and go on to the next one, really, this was supposed to be more like this. That's a better looking tangent line, huh? All right, well, you get the idea. So for this second one, I'm not really going to, well, actually, maybe we will afterwards to see if our answer makes sense. Just geometrically to see if it looks good. But I'm just going to go straight ahead and go ahead and use this difference quotient here. So m, I want to find the derivative at negative 1 because it's always the x value. You're finding the derivative at the x value. Right? So that would be the limit as h goes to 0 of f of negative 1 plus h minus f of negative 1 over h. So the other thing I always do so that I don't mess it up is I write down the difference quotient, because if you, even when you've done a lot of them, if you're just substituting, it's just kind of easy to lose negatives and stuff. So I always do like to write that down. If you guys don't, I won't take off points. I just think that you may find that it's a better practice. If I put this in here, remember I'm putting negative 1 plus h in for every x in there. So I have square root of, 1 minus 3 times negative 1 plus h. And then minus, and I know that it's 2, but okay, I'll just put it in there, since I don't have room for the next step anyway. Okay. So now you have this business, which also kind of looks familiar because we did a similar one. Not the same one, but we did something similar. So if I work this out, this is 1 plus 3 minus 3h, right? So this is going to be the square root of 4 minus 3h, and then minus 2. Actually, it does look kind of similar to something. I think there were 4s and 3s and some other thing we did earlier this week. Anyhow, it's the same deal. Because it's got that square root, there's nothing you can really do except multiply by the conjugate radical on the top and the bottom. See if I can fit it in here. When I have one of these, and as we go through and do more and more of them, you'll notice that I usually just leave the bottom alone. I don't spend my time multiplying stuff out on the bottom. I always have to multiply stuff out on the top because I'm trying, the goal is to get rid of this h. I'm trying to pull out some h so that I can cancel out the h's. So I always just leave the h there, and whatever, there might be bunches of stuff here, I just leave it, but I do write it every time. Even though, especially when it's something long, it's kind of a pain to rewrite this every time. But you risk, if you don't rewrite it, you risk completely losing it, and then you have the wrong answer. So even though I'm not going to pull the h through there, I am going to keep rewriting that. Now, when I look at the top again, it's like an a minus b times a plus b. So I'm going to have a squared minus b squared. So my a squared, though, is just going to be 4 minus 3h, right? Because it's square root squared. And then the b squared is going to be minus 4. So this is good, right? Because the 4's canceled out. So that's okay. That's good. That makes me feel happy because that happened last time and that worked out. And you see, now what I have is I have a minus 3h at the top, and then I have an h at the bottom. And then I have all this stuff. The h is canceled. Now I'm in a good spot. I've got minus 3 in the top. And the bottom, I have 4 minus 3h plus 2. Now, for the first time, because my h's have canceled, now I can take h to 0 and not get 0 over 0. I have, in fact, what do I have? When I take them, I have minus 3 over root 4 plus 2. So I have minus 3/4. So that's the slope of my line. Okay? So there it is. That's the slope of my line. Sometimes they'll just ask you for the slope of the line, and then you'll be done. But sometimes they'll ask you for the equation of the tangent line, which means that what you have to do is you got to take that slope, and you got to take your point, and you got to write it up as an equation for a line. So that's not hard, but you have, because you've done all the hard work already. You've done all this stuff, did all that, took the limit. You feel like you got the answer, and you did. You got the answer. But if they ask you for the equation, you better write that down too. So let's erase these for a half a second and write that down. Y minus 2 is equal to minus 3/4 times x plus 1, right? Minus minus. So I end up with y equals minus 3/4 x plus 5/4, right? Let me put it. So there's the equation of my tangent line. You will notice that it is negative. That's fine. It just means that the line is going this way. If I do graph this, I don't know exactly what this looks like. It's going to be something like here, right? This is going to be 1/3, and then it's going to be 1, and then it's going to be doing something like this. So it is going, your line is going to be doing something like that, and of course, well, it looks like it's a little bit less than 1. I don't know, but it's reasonable for this graph, which you can graph easily just by realizing that it's like negative x, it's like square root of x flipped over, moved over, whatever. You can tell that your answer, at least, maybe you had made, I'm sure this is the right answer here, but if you got the wrong number, you might not know, but at least you have the right sign.